This is a slightly different question on the JMO, a question about a game and finding an optimal strategy for winning, either the first player or the second player. Now, if you enjoyed this question, then you should check out the Mathematical Olympiad for Girls, because often the penultimate question is about a game and finding a strategy. Perhaps slightly trickier, but I don't know. I think this one's quite tricky personally. So anyway, up to you. I'm just giving a bit of signposting. Now, not expected to just immediately look at this and find an optimal strategy. I mean, I didn't. So what I did, first of all, is just play out a game, just to get a feel for what is actually happening. So the first player starts on 20, and they can eat between 1 and 10 sweets because they have to eat at least one, and they can't eat more than half of what remains. So yeah, they can't eat 11 here, they could eat up to 10. So I chose that they had 9 in the problem. So that means now the second player is, maybe I should just say that's the first player, that's the second player. Okay, then I said, okay, the second player, they can eat between 1 and 5. They can't eat 6, so let's say that they ate 5, then it would go down to 6. And now the first player would have their go again. Okay, I'm going to get them to eat 2. So 4, they could eat between 1 and 3. Right now it's the second player's turn. Okay, they're gonna eat 2. Now it's the first player's turn. Okay, they can only eat 1. So the first player would win because now it says the loser is the player who has no valid move. And that's when we get down to 1 sweet. So first player wins. Now this doesn't really help find an optimal strategy straight away, but at least it's getting an idea of how the game actually works. And I say it doesn't give an optimal strategy. For me, it actually gave me my starting point for the solution. So I thought, right, whoever ends up on 1 sweet is going to lose. So let's look at the person who ends up on 2 sweets. Well, they have to eat 1, but they actually have no choice. They have no choice to win, but other than to win at this point. So basically, if whoever gets onto 2 sweets is necessarily going to win. And here I am working backwards, back up to 20. So what if the person was on 3 sweets? Well, in that situation, they're not allowed to eat 2 because they can't eat more than half. So they can only eat 1. So they would have to go down to 2. So whoever ends up on 3 sweets is necessarily going to lose. And you can maybe see how the strategy is going to evolve. And if you couldn't do the question, maybe now that I've started you off, you could have a go. You could pause the video and then check at the end. Because I'm going to keep working like this. So 4. Right, whoever's on 4 sweets, they could either go down to 2 or 3. And so they could ensure that they go down to 3. And therefore, they can make sure that they win. Okay, if they go down to 2, then they're gonna lose because the other player would necessarily win. So you can see this building up. Now with 5, I could go down to 3 or 4. So if we go down to 3, like choose the 3, then again we can win on 5. 6. Now we can either get 3, 4, or 5. So we could choose to eat 3, take us down to 3, and then we would win there as well. Okay, that would be our optimal strategy. Of course, we could do a poor strategy and lose, but we can ensure that we win if we end up on 4, 5, or 6 sweets. Okay, so that's what player 1 or player 2 is trying to achieve. All right, let's take a look at 7. So with 7, then you can only end up on 4, 5, or 6. And that means you're going to lose because the other person will end up in a winning position. Okay, so you don't want to end up on 7. 8. You can get 4, 5, 6, or 7. Okay, so if you choose to just eat 1 sweet, then the other person would end up on 7 and they would lose. Let's go up here. So 9. So 9, you can do 5, 6, 7, or 8. So yeah, you can again eat 2 sweets and then the other person will lose. So you can win with 9. 10. I might be doing this in more detail than needed at this point, as long as you can kind of find a route through. But I don't know. I quite when I did it, I did it in this depth, and I'm going to carry on like this. I wrote down all the options. The key one is that we can get to 7. So that's all you really need to write. That's what I'm trying to say. So we can definitely win if we get to 10. And then with 11, 6, 7, 8, 9, or 10. Okay, because we can get to 7, we can definitely win there as well. 12. Maybe at this point I'll start shortening it a bit. We can definitely win on 12 because we can ensure that we get to 7. 13 as well. 14 as well. Right, which takes us to 15. Now, with 15, we can't get to 7 because we can only eat up to half of them. So 8 would be the lowest that we could get to. And actually, this is quite critical because these are the only numbers that you could get to, and in all of those positions, the other person wins if they choose the right strategy. So if you get to 15, you're going to lose if you're following the right strategy. So what that gives is an optimal strategy for player 1. Okay, they can eat 5. So 20 goes to 15. And then they can ensure after 15 that we get down to 7. Because player 2 can only, after they've done this, they can only get 8 to 14. So you just have to make sure, and you can see from my diagram that, yeah, we can get to 7. So when we're on 7, they either get to 4, 5, or 6. So then you can make sure that we get to 3. And after that, 1. So I hope that makes sense. That we can play out the game now. So, right, player 1 starts on 20. They eat 5 to take it to 15. Then player 2 is going to eat enough to get either 8 to 14. Okay, they can decide. Now, player 1 is back in it, and at that point, they eat however many they need to get to 7. They can guarantee that. Then player 2, they can either eat 1, 2, or 3, taking it to 4, 5, or 6. Then player 1 will necessarily guarantee that they eat enough to get down to 3. Player 2 will be on 3. They can only eat 1 to take it to 2. Player 1 then eats 1 to take it to 1. Player 2 can't go. So you could put that in writing, and I would definitely recommend some more words than what I've written here. The solutions, of course, this is like, a concise explanation of it. And it says much the same as what I've said, but yeah, you can't, you just need to have enough writing in there. I feel like I've explained it verbally, but it takes a little bit of time to write everything out, so I've not written everything out here. But so overall, the answer is yes. Player 1 can guarantee a win, and this is their strategy. Okay, neat question, and I hope you enjoyed it.